Hello everybody and welcome. Some of us find in this situation when we wonder how long does an e-bike battery last. But in real life we are not e-bike experts or electricians, so I'm gonna give you some simple life examples and you will understand how a battery works. Now either you want to buy an e-bike or build it up yourself, there are in general three types of batteries that can be found on an e-bike. First, we've got lead acid batteries, which are very similar with those used on cars or e-scooters. It's probably the cheapest way of building up an e-bike, and if you live in China or other Asian country, you can buy an e-bike with this configuration already built it up from shop. However, in European or American countries, you must be able to build it up yourself. Second, we've got lithium-ion batteries with Samsung and Panasonic cells, which can have different chemistries, but I will not get in details right now. This can be made in different shapes, power and capacity and can last up to 1000 cycles if properly used and charged. Then there are other lithium models out there which are mostly used on electric cars, hybrid cars, power tools or cell phones, and those can sometimes catch fire, be more expensive or release high energy in short time. So there are enough reasons to not want them on your e-bike. Now we will take a look on this group of Li-ion batteries, which are the most logical and appropriate ones to use on an e-bike. All the batteries in the world have two main features to look for: voltage and capacity. Now imagine a bodybuilder training with his weight. We can associate his muscle with the battery, the weight he's lifting with the number of voltage, and the number of repetition he can do with the number of amps. Now, if we increase the number of amps or repetitions, it means that the weight will travel longer and the battery has to be stronger, right? Now, let's take a look of those two numbers. If we multiply them, the result will be the total watt hour that the battery can produce. So in this case, we have 468 watts hour. So with another words, it means that the engine can use 468 watts in 1 hour running continuously. Let's take some hypothetical examples of one cyclist going on different roads in different conditions. The bike will have the battery that I mentioned before, 36 volts and 13 amps, with a maximum discharge of 468 watt hour. In this first example, his total weight is 100 kilograms and he will run with 32 kilometers per hour on a flat road and not pedaling at all. Obviously, if he does not pedal at all, he will use throttle, and so the engine uses 468 watt hour all the time. The weather is mild, there is no wind coming towards him, and what will be his range in these conditions? It will be 32 kilometers per one battery charge, because the engine uses 468 watt hour all the time. Let's say that he wants to pedal and help the engine, which will use now only half of energy, 234 watt hour. He's running on the same speed of 32 kilometers per hour with no wind on a flat road. In this case, the range will be 64 kilometers for one full battery charge. It means that the engine can run 2 hours using 234 watt hour continuously. Let's say that our cyclist wants to pedal hard on a 35-degree hill. He must arrive to his destination, which is 32 kilometers away. He will run with 24 kilometers per hour, so he will arrive there in 1 hour and 20 minutes. Meanwhile, he is using 234 watt hour from the battery. So his total range will be 48 kilometers per one full battery charge. Now in this example, we can see how much of a difference will be if we run on a hill. In the last example, let's change the degree of the hill, the total weight of the bike, and the speed of the wind. If you will not pedal at all, the engine will use 468 watts from the battery all the time. With a speed of 5 kilometers per hour, his range will be 5 kilometers for one full battery charge. In real life, this type of conditions are not very common, but at least it shows you what a big difference in range a battery can have upon different cycling conditions. In conclusion, there are in general 7 factors that will determine the range of your battery. How much you want to assist the engine by pedaling, what is the degree of the road, what is the condition of the road if there is any snow, mud or water, the speed of the wind, the total weight of the bike, how you change the gears, and the pressure in the tire. Most of bikes from shops have different level of pedal assist. For a 36 volts and 13 amps battery, it can look like this. From the lowest level of assistance to the higher one, there will be a certain amount of watt-hour which will be taken gradually from the battery. That's why you must look at the voltage and amps, multiply them and get the watt-hour total of energy. What if there is a battery that has the same total amount of energy but different configuration? Well, in theory they will be able to push your bike at the same distance but in different manner. For instance, a 48 volts will go faster than a 24 volts battery. Now, in real life, you will not find many 48 volts with just 9 amps. Usually they will give you a reasonable amperage, so you'll get also a reasonable range. Alright guys, thanks for watching. I hope you understood what I explained about batteries. Now I'm gonna go and take out some watt hour out of this. Subscribe if you want to, and see you in the next video.